Hey guys. Hey Ashwath. Hey Divyaraj. Guys, are you able to type something in the chat? Can anyone give me a confirmation? Yes. Perfect. Hello. How was the editing? Hey Akshat. Did anything special today or no? Guys, we'll wait for a couple of more minutes and then we'll start the session, okay? No. Good to know. Hey Param. Good morning.
Good morning.
How are you? How's everything?
All good. How are you doing?
Yeah, doing good. Thank you. Hey Sorin. Hey Sandeep.
Aman,
Hello. Okay, I'm disabling the audio part of you guys so that we can continue with the agenda, and then maybe in the end I'll unmute all of you if you have any questions, okay? So I think we are good to start. Yeah, so hi everyone, welcome to the session. Thanks for taking out the time and deciding to learn something new. I'm expecting that this topic would be very new to you guys because not a lot of people have even heard about it and forget using ClickHouse as a company or ClickHouse as a tool, okay? So the agenda of today's class will be for me to introduce all of you to ClickHouse. What is the meaning of ClickHouse? What is the company? Who is the company behind it? What niche problem they are solving? They are a database or data warehousing company, by the way. Obvious question that comes to me is, hey, we already have a lot of data warehouses, right? Why ClickHouse? Why another warehouse in the market, right? I'll talk about that. And then I'll talk about like the reason why you should use it. I'll give you a very brief live demo that why there is a very clear benefit of using ClickHouse in your organizations as well. And then I'll give you some roadmap of how do you proceed from today's session. Okay. So before beginning, a quick accessibility check. Can you all see me? Can you all see the screen I'm sharing? Currently, I'm sharing my Excalibur whiteboard. And can you all hear me also? I'll need at least one yes. Yes, perfect. Hi, Sandy. Cool. Before beginning to tell you what is ClickHouse, how many of you have already heard about it or used it? I'll need some yeses, and meanwhile, I'll open the browser and show you a few articles because I'll show you some niche use cases where ClickHouse are used. ClickHouse is used in today's market. Okay. So I have opened few articles and nope, haven't used. Cool. So, by the way, there is one thing which is very common in Anthropic, OpenAI, Lovable, Character.ai, Uber, Meta, that all of them uses ClickHouse. Okay, not throwing anything in thin air. Will give you some proofs. Anthropic, again, $1 trillion companies, $800 billion investment they took, I think, in the last month only, and they are using ClickHouse as their warehousing platform to enable the observability. I'll talk about observability in maybe in few next minutes, but just FYI that even if you haven't heard about ClickHouse, almost every new company which is coming and trying to solve things at scale, they are using it. Okay. Even ClickHouse, even OpenAI is using ClickHouse as well for the observability. I'll talk about observability in few minutes, but yeah, just giving you a few glimpses of where this warehouse is used. Lovable, in case you do not know, Lovable is a website that lets you create some very quick prototypes. It's like trying to democratize the web development. And they also use ClickHouse, and all their log analytics is done by ClickHouse. Okay. Character.ai, company which lets you create characters for the games and the 3D assets, they are also using the ClickHouse on their GPUs. Okay. These are few of the names I'm taking who are using ClickHouse in the environment. If I go to the main page, that is clickhouse.com, you will see that, of course, the jargon that, hey, we are for AI. Microsoft, eBay, Spotify, Lyft, Hotspot, HubSpot. Think of any new company who is trying to work at scale, they're using ClickHouse. Okay. You would have heard about things like Databricks, you would have heard about things like Snowflake, but trust me, when we talk about when we talk about scale, no one even comes to the place where ClickHouse is currently working and operating at. Okay, so this was the first thing, that it's not just me telling you some niche topic to upskill upon. Companies are using it and it is solving a real life problem statements also. Okay, this was the first problem statement. This was the first insight that I wanted to give, that hey, it's widely adopted nowadays in the market. I'll tell about why you haven't heard about it or why your company is not using it as of now. Okay, I'll come to that also. But just in one line, what is ClickHouse? ClickHouse is a warehouse. Okay, I'll just append few keywords before it and then it will make the definition clear and full. So it's a warehouse. Okay, you will see words like analytics, analytical, or columnar. Okay, because every analytical database is a warehouse. So all these three keywords are synonym to each other. Okay, so whenever you will read about ClickHouse, you will find these three keywords, but all of them means the same thing. Okay, but this is also true about Snowflake. It's also true about companies like Databricks. What's special in ClickHouse? I'll add two more words. One is open source. Okay, and the best part is real time. Okay, whenever you talk to someone, these are the only two selling point of ClickHouse. Okay, it's open source and it's real time. One plus point would be it's blazingly fast. Okay, when I say it's fast, if I take 50 million rows and if I have to ingest 50 million rows and if I have to do analytics on top of those 50 million rows, give me any rough estimate how much time it will take me in ClickHouse. 50 million rows, I want to do analytics. Let's say I want to group the data and take the sums and the mins and the max. How much time it will take to query these results? Any wild guesses? You would have used Power BI, you would have used Snowflake, you would have used all those things to refresh your data, right? Any guesses how much a fact table with 50 million rows will take to refresh it to give you insights? Hi Pradeep. Hi Satvika. Hey Harry. Mm, 2 minutes, 7 to 8 minutes, okay? So I'll give you the example of live test. Okay, we'll do the live POC in this class only. We'll take 50 million rows. We'll insert the 50 million rows into a table. We'll do the analytics on top of it. We'll take sums and the group bys. Okay, it will take you less than half a second. When I say extremely fast, this is the meaning of extremely fast. Okay, when you work with things like Power BI, you know how much time it takes. When you work with Snowflake, right, you know how much time it takes. That insight which I'm getting in the chat, 7 to 8 minutes, 2 minutes, more than 2 minutes, right? That is on the legacy warehousing tools like Snowflake and Databricks. When we talk about ClickHouse, we're talking in milliseconds. Okay, so this feature, like, it's extremely fast. I'll tell you the technicalities behind them also, that why they are fast and why Snowflake, to be very frank, can't achieve these numbers. We'll talk about that also, but this is non-bookish definition of ClickHouse. Warehouse. Warehouse means we can do analytics on top of it. So that's why it's a columnar slash OLAP slash analytical warehouse. And it's open source. It has two versions, by the way. When it was launched, when it came into the market back in 2007, it was introduced by a team from Yandex. And then it was open source, but then they introduced a newer version of, or maybe a different version of ClickHouse, that is the managed or the serverless. Maybe you can purchase the cloud of ClickHouse also. So nowadays they have open source version also, and they have ready to pay also, that if you want to manage everything on your own, they're very fine with it. Choose the open source version of the warehouse. But if you want them to manage cloud for you, they have the paid version for the same. Okay, and it's real time. In this word is the secret hidden. Why Snowflake? What's the use case of ClickHouse? Okay, whenever we talk about Snowflake or whenever you guys think about analytics, right? What is analytics? You will say that, hey, I'm building a dashboard, sales dashboard, finance dashboard, maybe inventory dashboard, and I'll create some reports on top of it. That is analytics for us, right? So there are two kind of analytics. One is batch analytics, one is real-time analytics. Okay. Whenever we think of analytics, because mostly we work in non-product companies, we are not working in a companies who are solving a very hard problem of the world. We work in this era. We work in this bucket, that is batch analytics. What do we mean by batch analytics? That no one wants a real-time data. Okay. If I'm creating a sales dashboard, no one cares if the data is coming at 12 a.m. or if the data is coming at 12:20 a.m. Doesn't matter for them, right? So that's why whenever you think about databases or warehouses, typically we incline our thinking to these kind of operations, that we are supposed to do batch analytics. Batch analytics means there are, I'll tell three parameters of judging which, like, parameters decide that is it a batch analytics or is it a real-time analytics. Okay. One is query latency. Second is data freshness. Third is users. Okay. Whenever we think of analytics, we are thinking about batch analytics. In the batch analytics, query latency could be seconds to milliseconds. If I'm writing select star, it can take seconds, minutes to load the data. I don't care. When I talk about data freshness, data could be delayed by few hours to few days also. It doesn't matter to me. Okay. When I talk about users, very important factor. Typically, we are building dashboards, reports, analytics for internal users of the company. That could be 50, 100, 200, 300. Okay. These parameters, when your data could be delayed by hours and days, doesn't matter. And only the company's employees are going to use your dashboards and analytical pipelines, is called batch analytics. In this case, you can use anything you want. You can use Snowflake, you can use Databricks, you can also spin up a DuckDB warehouse and start the analytics on top of it. But the problem starts appearing when you work on a real-time analytics. What is real-time analytics, by the way? Nowadays, whenever you see a product, every product, again, think of LinkedIn, think of YouTube, think of Instagram, right? Every single product nowadays shows you your own personalized dashboard also. If you're talking about Instagram, maybe they'll show you how many seconds you have watched a reel. Maybe, like, if you talk about LinkedIn, right? If I go to LinkedIn here, they in real time they are showing me how many likes I have received on my dashboards, right? So if I show you this, I'll show you the meaning of real-time dashboards, and then I'll tell you why ClickHouse is better uh, candidate for that. Now, if I show you the analytics dashboard of LinkedIn, this is how it looks like. Okay. If I show you for past 365 days, they will show you real time how many views you're getting, how many likes you're getting, for example, right? If you go to your home screens, you are seeing how many likes a post has, and this is almost close to real time also, right? I'll give you few more examples of what do we mean by real time analytics. Here also the aggregations are happening, right? The LinkedIn engineers are writing select count distinct, and then they're showing the distinct count here as a number of likes, for example. This is also analytics, right? Now if I show you maybe Uber stock, okay, whenever you go to maybe Zerodha, maybe some any stock market quote unquote website, they also show you dashboards, right? But these dashboards are real-time dashboards. They are getting data in real time and they have to show you the data in real time. They can't delay the data by a second or a minute or so, right? Because the real-time pricing decisions are taken based on these costs. These kind of things where the products have the dashboards integrated inside the product. If I go back and talk about these three parameters, the query latency, I'm talking about milliseconds. I can't delay my data more than a millisecond, because then of course depends on the use cases also, by the way. For example, if I'm building a dashboard or analytics for a maybe pricing stock exchange company, right? I can't expect a delay of more than a minute or two. I talk about data freshness, I'm talking about maybe a millisecond could be a delay, right? When we talk about batch analytics, we set up scheduled refreshes of maybe hourly refresh, weekly refresh. We can't do that in real-time analytics dashboards. Even the users, right? We are talking about millions and millions of users, because every single user gets their own dashboard and they consume the insights on top of it. This is the difference between batch analytics and real-time analytics. Whenever I talk to someone and talk about analytics, they mostly think about this, that, hey, I have to build a report. That report will be consumed by 100 to 200 users, and that's it. But the place where ClickHouse, maybe some other tools also, I'll talk about them also. These tools are operating is this layer, that real-time analytics. Maybe they are a very commonly used keyword is observability. Okay, what is observability? Every tool, every product is releasing the logs also, right? That hey, in this second my website is up, in this second something happened to my server, right? They collect the log data, they collect the click stream data also. What is a click stream data? Whenever I go to a website, I'm clicking something, I'm typing something, I'm interacting with the website, right? Every single click, every single interaction gets captured and gets stored in the database. That's called click stream data. When we talk about this amount of data, we are talking about petabytes of data. Okay, that means you have to show petabytes of data, consume it, do analytics, and show it the results to the users. In these cases, Snowflake's Databricks, think of any other OLAP database, will fail because they are not built technically to solve this use case. Okay, so Snowflake, Databricks are solved or built to solve they're built to have a very general purpose data warehouses. What is general purpose? That hey, you load the data inside me, I'll help you do the analytics, I'll help you do almost everything, but it's not going to be real time. It can be real time, but these three parameters will suck a lot. The query latency will be a lot, the freshness will you will need to struggle, and of course the users will need to continuously increase the servers and the computes to make sure that everyone is using it. Because of these three parameters, no one uses Snowflake, Databricks, and some other warehouses, some general purpose warehouses for the real-time analytics. And this was the term I was talking here. Now, if I go to the few more articles, I'll tell you that when I'm saying that, hey, ClickHouse is way, way, way faster than Snowflake and Databricks, I'll show you some proofs also that is it really fast or not. Okay. I'll show you two comparisons. One is with Snowflake and one is with PostgreSQL. Snowflake is OLAP database. PostgreSQL is OLTP database. Of course, this is just 1 hour class. I can't go into very much details of what is overlap, what is OLAP, what is OLTP. If you're interested, this class is part of cohort. You can join that course, and then these things are talked in very detail there. But just giving you a few benchmarks. Snowflake, by the way, is considered to be the most fastest data warehouse in current industry. Okay, and this is the Snowflake versus ClickHouse. ClickHouse is 4x cheaper, the queries are 5x faster, and the compression of data which ClickHouse does is 38% better compression. Okay, these are the benchmarks. I'll give you insights about how this is done also, but just giving you a few insights that hey, they are really, really fast. Okay, if you compare it with the OLTP databases, they don't even come to the feeds of the ClickHouse, right? PostgreSQL is the fastest OLTP database, but see the comparison. In ClickHouse, you can get the response of a query 1000x faster. The space or the storage that you will need to store the data in ClickHouse is 50% less than you will need in PostgreSQL. The cost saving is also 5x, right? These are the benchmarks. These are the reasons that whenever a product based company, I'm not talking about some consulting companies where you and me work. I'm not talking about some CPG retail companies where they want to do batch analytics. I'm talking about companies who are interested in real time analytics, who have built a product and they have scaled a product to millions of users and they want to do analytics for them. For them, these are the numbers that matter. They want data to be shown faster, they want data to be shown cheaper, and open source is also a very big factor because they don't want to rely on some product vendor lock-ins and everything. Okay, because of this, almost every tech giant nowadays is relying on ClickHouse for the analytics, like the factors which I was showing you here. Anthropic is using it, OpenAI is using it, Lovable is using it. All these companies, right, which you see here, they're using it because they want to do real-time analytics. That too, like, the technicalities should be, I want it to be open source, I want to be faster, I want to be cheaper. Whenever you pick a tool, or whenever you pick a product or a maybe platform for your company, right? To be very frank, only two things matter. One is cost, one is performance. Everything else is just good to have. Okay, must have is just these two factors: cost and performance. And I already showed you ClickHouse is open source, so companies don't have to pay anything to use ClickHouse. The performance, I gave you the reasons that hey, this is way faster. I haven't given you the reasons why it is faster, but just giving you a few pointers that this is actually very fast. I have something in the chat. Is ClickHouse common? Haven't heard about them. Yes, we haven't heard about ClickHouse because we are not solving those problem statements. Okay. If I show you this insight again, mostly we are solving batch analytics. When you work in a good company who is having their own product and who are doing real-time analytics, that's where the ClickHouse is used. So even though we haven't used it, the reason is because we are not working on a very insightful, very interesting problem statements, to be very frank. Okay. But just to show you again, just go to the ClickHouse website. They have a plenty of use cases, plenty of case studies also, that which companies are using them and why they're using ClickHouse. Okay, so almost every company which is serving the front end users analytics dashboard, they're using the ClickHouse as a service. Okay, now this was the introduction that hey, ClickHouse is a warehouse and it's open source and it's a real-time warehouse. So whenever someone wants to do observability, whenever someone wants to get petabytes of data, whenever someone wants to do real-time analytics, and whenever the dashboards are built for millions of users, not for some 100, 200 users of Power BI and Tableau, that's where the ClickHouse is used. Okay. Now, just to deep dive a bit more, that why is ClickHouse fast? What did they do technically that Snowflake and Databricks weren't able to do? Okay. So I'll go to the drawing board again and try to tell you a bit of a technical architecture of ClickHouse. Okay. Meanwhile, if you have any question, you can ask me in the chat. Okay. Uh, TC architecture. Okay. I won't go into each and every point, but I'll try to explain you that why is the reads and the writes faster in ClickHouse. Okay. Whenever I was talking in the starting that hey, it's really fast that for 50 million rows it will take me half a second to do the analytics. Okay. Maybe I'll do one thing. Before telling you the architecture, I'll give you a very small demo of using ClickHouse real time and telling you that is there any benefit of using it or not. Okay, and then it will make life easy for me to tell you guys that what's the reason behind the cost and the speed of the same. Okay, so maybe I'll do one thing. I'll go to my code here. I have something in the chat. How do we connect ClickHouse to cloud or platform? Is there any connector recommended to connect ClickHouse with cloud? Yes. So Param, there could be three factors. So whenever you connect to any third party system, could be any data source, either you connected with the JDBC or ODBC drivers. Every single tool release their JDBC, ODBC drivers, you either connect with them, or ClickHouse also has the inbuilt connectors, right? You just import the connector and start using it. So they have almost every single connector present and possible in the world. Okay. So we'll do one thing. I'll quickly write very small code. Maybe we'll generate some millions of rows and then we'll do analytics and I'll show you the speed and the cost it will take me to do the analytics. Okay. So I'll create a Python file. Again, it's a open source and the beauty of open source warehouse is this, that I don't need to sign up anywhere. I don't need to purchase anything. I don't need to enable any server, any warehouse. I'll just write my code, write one line to import ClickHouse and that's it. Okay, this is the beauty of ClickHouse. So maybe I'll do one thing. I'll import few libraries. The first library is time it because I want to time how much the query is going to take. So I'll import the time it library and I will import the ClickHouse. How do you import ClickHouse? So there is a library called CHDB. CHDB means ClickHouse database. And from this, I'll import the session. Session import session. Okay. When you import a CHDB instance, of course, you need to install CHDB library that is already installed, but that's nothing but pip install CHDB, right? Not going to take a lot of time. With this session, you can start a ClickHouse server on your system by just writing session, and your session will be running somewhere on your local computer. So maybe I'll have something on my file. I'll give some file name. Maybe within this folder, I'm saying that create a file called D. Okay. I hate this AI. Wait. Yeah. And oops, give me a second. Once you start a session, your ClickHouse session will run on it. You can simply write query. And now your ClickHouse instance will be up and running, and now you can start writing any query. Your query could be SQL query to write a table. Your query could be SQL query to insert some table. You can do anything you want. But think of the Snowflake experience. If you had to start writing queries, first you would have to go to Snowflake, sign up on their portal, give your credit card, insert a table, go to UI, click 4 or 5 buttons, and then start writing query on top of it. Compare that experience with this experience. With just 3 line of code, I'm able to import a server. I'm able to start writing query by just sake of in whatever IDE I want to. And my laptop can have 1 GB, 2 gigs of RAM also, doesn't matter, because ClickHouse is very fancy in the technical architecture that they don't care, to be very frank. Okay, so let's do one thing. First query I'll write is I'll try to create some tables. So this will be create table. Okay. Uh, Always whenever you're writing SQL query, a small tip from my side, that started with the 3 queries, because 3 inverted column, because then you can go multi-line. Okay. So I'll create a table, create or replace table, a typical DDL line. Mm, I'll give it an engine, because whenever you start working with ClickHouse, there are few of the engines that you can use. It's suggesting me Stripe is one engine, but we'll use Merge Tree. Merge Tree is their infamous engine, which is a columnar engine, right? I'll use Merge Tree as engine. And then whenever you work on creating a table inside ClickHouse, the one thing you need to realize is ClickHouse always expect you to give them a sorting key, that it will always store the data on your disk in a sorted manner. Okay, so always give it order by key. So order by, if you have some column which you want to use for order by, you can use it. If you want to keep the order by key blank, you can do that also. Just write tuple. Okay, these are the two commands. Okay, this is wrong. These are the only two commands that are special and relevant only for ClickHouse. When you work in MySQL, Snowflake, Database, you don't configure that. But in ClickHouse, that's a requirement. You can skip it also, but typically don't, because this helps ClickHouse to make things fast. Once you do this, now you can start writing your SQL query. Okay. If let's say I want to generate 50 million lines of code, maybe 50 million rows in my data, can anyone give me any suggestion how can I do that? I want to generate 50, 100 millions of data by just writing 2 to 3 lines of code. How can I do that? Anyone in the chat? How do I generate the data now? I need some dummy fake data. Meanwhile, I'll write the code. And till then, if you can suggest me, how do we generate fake data? Because typically, whenever I talk to someone that, hey, have you worked on some larger data sets? They typically say, hey, how do I get that data? So ideally, you can skip all that stuff, because if you know some functions of Python, there is a rand function. With that function, you can generate any amount of data you want. So maybe I'll do one thing. I'll use rand function to generate some random values. I'll call them as revenue. And this could be one column. I'll generate one category column also. Rand as category. This will generate some random categories for me. If you want your categories to be defined only in some specific value range, for example, you want your categories to be only maybe 0, 1, 2, you can do that very easily by just taking the modulus. If you do this, that hey, generate any random number, but it should only be between 0 to 2, that's a code here. Okay, so you write rand, it will give you a random number, but you make it that hey, it should only be bounded between 0 and 2, and that's why you do it. So one column I can have a category, and then I can have some user ID. So maybe I'll take again the rand function. And if I want to generate user IDs between maybe 0 to 9,000 or 9999, I can do that by taking modulus of 1000. Okay, this will be my user ID. This is giving me one row, and one column will be revenue, one column will be category, one column and category will have values from 0 to 3, 2, and user ID will have values from 0 to 999. That's how the that's how the modulus function works. Okay. Now from where do I need to select the data? I don't have any data. You need to generate an array, and that array will be your data. ClickHouse and almost every database system gives you a function called number. Whatever number you write here, you will get those many number of rows. Okay, this is the easiest thing you need to do to generate data, to generate fake data. This will give me 50 million rows. Three, no, it's 5 million. So this is three, this is three. Yes. This four line of code will generate 50 million lines of code for me. 50 million lines of data for me. Okay. This is the generation part. Now, if I want to do analytics on top of it, what is analytics? Maybe taking group bias, taking sums, the cost, the min and max. How do you do that? I'll write some query. Select, maybe I'll select the category and I'll take some counts and I'll take some sums. I'll take sum of revenue mm, from, this is the table name, E. I'll take some group by also. This will help me to make my query more complicated. I think I'll categorize it by category. This is going to do the analytics for me. Mm, this and yeah, I think we should be fine. Now I'll log the result, see the results, timings. I'll start printing it. To print the data, I'll need to start my session again. This is my session. I will take my session here and I will, yes, dot show. Use this. So what I'm doing is I'm starting a ClickHouse instance. I'm writing a query. I'm saying that this is a SQL query I want to run. Okay, nothing fancy. And I'll show my data. Uh, I think this show I should not use. I'll use pretty compact. Pretty compact. Give me 1 second. I'll just write my code and then I'll explain you what's happening here. Okay. This will give it and then I will write seconds. I'll use the time it library to time it how much time it is taking. Okay. Time it dot time it. I'll loop over my function session. The function is, or maybe I'll take it from here. Not query. I'll run my SQL query and I'll run it only once. Number is equal to 1. Okay. So what I'm doing here is just to reiterate, I'm importing a time library, I'm importing ClickHouse database, I'm starting a session of ClickHouse. This will save my data inside a file called D. It will create a folder called D, and I will start creating a table. For table, you need to write a SQL query, and this is how you write a SQL query. Every single query you need to write need to be wrapped inside a query function. Okay. And then I'm starting my table. Table will have one column called revenue, one column for category, one column for user ID, just some random numbers, and the 50 million rows. Okay. Then I want to do analytics on top of it. So I'm writing category count. It should be count, sum, and I'll just group by data. Right. Now then I want to run this query because here I have just written the query. How do you run the query? I just told you every time start the session and write dot query function. So I'm starting the session, writing dot query function. I'm passing pretty compact because this will give me the log data in some tabular format. It will be easy for me to explain you guys. And then of course I'll need to time it, how much time it is taking. So I'm using time it library. And in this function, you just write what do you need to time. So I'm timing my session, the query, the SQL query, how much time it is taking. I'm writing it here. And I just want to run this once and do the timing. So number one means just run the query once. And then maybe I should print it. So print. Okay. This is the bare minimum code you will need to write to do the POC maybe. Okay. If I have written the code correctly, I should be able to run this. So let me see where my path is. Makes sense. Python 3 app.py. Okay. Of course. Mm, Give me a second. This is failing at this side. Line 6, right? Yes. I'm starting a D. I'm writing a query. Query is in three inverted commas. Mm, Create or replace. Engine is mastery. Order by as this. From, I think I know why it should not be number, it should be numbers. Now let me try it again. 3. Yes, perfect. I'll clear my terminal because it's too messy and then I'll run the query again, okay? Yes. So the pretty function here I was writing just because I wanted to show the results in a faster way. Now see here. I'm able to insert the data inside a folder called D. 50 million rows of insert has happened. And then I'm writing aggregated query. And this query that select category, do the sum, do the count from, and do the group by has taken 0.4 seconds. On 50 million rows, I'm taking 0.4 seconds. And I haven't done any optimization of my query. This is the bare minimum query I have written. If I would have done some optimizations, I would have done some query writing in the way ClickHouse expects me. This goes below 0.1 second also. This is the result I was talking, that this is blazingly fast. You guys would have worked on Snowflake, you guys would have worked on Power BI, right? You know that if your Power BI has 50 million rows, how much time it is going to take to query the data. And this is in front of you, that you don't need to do anything to use it. Just start a Python file, start an instance of ClickHouse, and then do the analytics. In the last class, someone told me, Sahil, why do we need DuckDB, right? Why do we need these low hanging headless? By the way, these tools are called headless, quote unquote. Headless means you don't have any dependency on someone else. Just import the library and start using it. I'll give you a real time use case. Yesterday, I was trying to build a CRM for me. What is a CRM? CRM is a place where I can save my customers' details, names, phone numbers, and the session in which they are signing up for, right? Because you guys sign up to my sessions, and I have to build a CRM. To build a CRM, but the process I wanted was Zoom always gives me, let's say this Zoom session will be ended, right? It will give me a CSV. The CSV will have all the details. Now, after every Zoom session, I would have a CSV. Now, the workflow I wanted was I will take every CSV and convert it to some queryable table on which I can write my SQL. How do you do this? How do you take your CSV file and write SQL on top of it? If you don't know these tools, the workflow would be you will sign up for Snowflake, pay them some money, import the libraries, import the CSV into Snowflake. Every time do it automatically, manually, and then build a dashboard. What I had used was I just started a ClickHouse instance, imported my data DuckDB, because DuckDB allows you to write SQL directly on CSV file, imported all the CSV into one folder, use DuckDB to start writing queries on top of it. This is the real-time use case. I took less than 30 minutes to build a CRM for me. If you guys do not know these tools, things like DuckDB, things like ClickHouse, you won't be able to convert your ideas, your thoughts to some real-world applications, because the process of signing up, installing things, giving credit card information is too big of a hassle, right? So this actually solves a big of a hassle, that you don't have any dependency to start doing analytics on top of your data. Okay. So this was one example. I wanted to show you the example by 1 billion rows, but I can't show it right now because my Zoom crashes. Okay. And but the meeting would end. But maybe in my Discord, okay, I'll give you the example. I was doing it and took me 2 seconds. Okay, I had to optimize my table, but took me 2 seconds to insert 1 billion rows of data. Okay, I was also reading an article, and Uber, by the way, also solved the same problem, right? Whenever someone books a Uber, the Uber has to continuously show you guys how much distance is spending. The real-time data is getting transferred, right? And they wanted to, because every single second, microsecond, the car's location is changing, and they have to send that data to the warehouse, do the analytics, give the result back to my user, that 15 minutes pending, 20 minutes pending. This is the real-time analytics, and Uber was able to scale it to 1 million rows of writes within a second. Okay, this is the speed. When I say, right, don't think of speed as you are building some CPG dashboard and you're expecting that, hey, it's taking time. It's not, it doesn't matter. Okay, so this is the reason. This is the proof that ClickHouse is fast. Now I'll tell you the reason why ClickHouse is fast. Okay. Of course, you can read the documentations. This will tell you the reasons also. But in ClickHouse, generally, whenever we measure any performance, performance is measured on two factors. One is on read, one is on write. I'll give you both the factors. Okay. If I talk about read, maybe I should draw both of them first. And if I talk about writes, okay, the reason ClickHouse is very fast in reading the data, number of reasons. One reason is it's columnar. Okay, the meaning of columnar is if I have this data, I should use Excel by the way. Give me a second. Sheets. I'll give you very maybe 1 or 2 minutes of information on why columnar is very important to make things faster, and ClickHouse uses it. So let's say you had two rows, row one, row two. Okay, and it has a data of maybe name, and we had phone, and we have country, for example. So this was the table. Okay, and I'll just zoom it a bit, and let's say name was N1, phone was P1, country was C1. Name again was N2, phone was P2, and country was C2. Okay, let's say very small data, and this is how a typical row and column data looks like. By the way, whenever we see or representable data like this is not the way the data is stored on disk. Okay, this is called logical representation of data. Okay, when you work with OLTP systems, OLTP systems mean MySQL, it means PostgreSQL, let's say. Okay, the most famous ones, PostgreSQL. Okay, how the data is stored is data is stored at a row level. Okay, that means first my database will take entire row, store it on the disk. Then it will take the next row, store it on the disk. This is the technical architecture behind the OLTP system and the databases. I should move it here. I don't need the AI. Okay, so when we talk about OLTP systems or the row level systems, the data is inserted at a row level. My database will take the entire row, place it here. Then it will take entire row again, place it here. What is the benefit of this design pattern? The benefit is the write or the amount of time it will take me to write the data into my system is very, very, very fast. Why? Because my database has not do not need to do any processing. They will just take the entire row, dump it. Take next row, dump it on my system, on my disk, right? So the writes are very fast here. But what about reads? Reads are slow. What do we mean by reads? Or maybe analytics is slow. I'll write it like this. Okay. Analytics or reading is slow here because let's say instead of country, this was called sales. Okay. Because I'll need to prove you something. Now let's say what is analytics by the way? Analytics is doing aggregations on top of your numbers. Now let's say your data was stored in some OLTP system, maybe MySQL, and now you want to do analytics. That means you want to do maybe sum of sales. That means you need to have first take C1, then do plus, then take C2, do plus, and sum all the rows, right? If your data is stored like this, first your database, and let's say if you're doing analytics and you're doing sum of sales, your first you'll need to come to C1, save it, and then hop again, find C2 again, skip these two memory blocks, locations, capture C2 again, then save it, then go again and again and find where is C2 and then capture it again and then save it in some memory and then do the sum. This process of hopping again and again, trying to find where my next value is present, is very tedious, and that's why it takes a lot of time to read it. What does OLTP or columnar systems do like ClickHouse is, if I take it here, they instead of storing the data row wise, they store the data on disk column wise. What do we mean by that? First, they will say save N1, N2. So insert paste special transposed, and then they will save P1, P2. They will save it like this, and then they will save the third column, the sales column, C1, C2, and then that will be saved like this. This is the way your Snowflake, Databricks, DuckDB, ClickHouse saves the data. Okay, that's why they're called columnar storages. Now, in this kind of design pattern where you are storing the data on a disk at a column level, the benefit is doing analytics or reading the data is goddamn fast. Why? If same problem I wanted to solve, I wanted to take the sum of sales. I just want to know where is my first value present. that is C1. I'll come here. Now I do not need to hop any location because all the other values are saved consecutively on the memory. Now I can have C1, C2, C3, C4. I'll just do the sum of it. I don't need to hop, find C3, hop, find C4, right? Because of this reason, because data is stored in consecutive memory blocks in a OLAP system like ClickHouse, reading is way faster. But this also comes with the conclusion that if reading is faster, the writes will be slower because see how I'm storing the data. Ideally, I have this row and this row, right? When I'm saving the data inside my OLAP system, I'm taking it column wise. But hey, there is nothing called column, or there is only one thing called transaction, right? Whenever customer inserts data, only one row exists and then the new row will come. That means when you write the data at a column level, this is how the write will happen. First, I will take the N1, place it here. And then I'll come here, take the data, place it here. So the writes are very slow because whatever was the problem in reading that I have too many hops, I shifted that problem to writes. But that's fine because in OLAP system, I don't care how much time it takes to insert the data, right? But this is the design pattern of OLAP systems like ClickHouse, and this is the reason why the reads are very fast. The example which I did here, that it took me 0.4 second to sum my 50 million rows. If I do the same kind of operation on my MySQL server or PostgreSQL, which are OLTP system, it's going to take minutes and minutes of time. Reason? Reason is this, because data is not saved in the consecutive memory blocks. Okay. So whenever someone claims that they are columnar, this is the first reason they are fast, because the data is stored in consecutive blocks. To do the aggregation, I need to see all the rows and I can just come to the first row and take the sum. That's it. The second reason why they are fast is, I will write that in my document also, is compression. Okay. The second reason why the reads are fast is compressions. I'll talk about some encodings also, but just to give you very few glimpse of why compression is very fast in OLAP systems like ClickHouse is, in this system, by the way, compression is always fast when you have the same kind of data present close to each other. That means in this case, in OLAP system, if I had C1 and C2, right, both of them are integer. Now, if both of them are of same data type, I can very quickly do the compression of my data because everything is of same kind. The metadata is going to be of same type. The memory blocks or the memory chips or the memory bytes it's going to take to save my data is going to be of same bytes, right? That's why compression is faster. In this place, compression was way expensive in OLTP system because I can't compress a string column with the numerical column because string requires a different number of bytes than a numerical column. That's why one of the another reason that why reads are faster in my OLAP system is because data is stored of same type after in the consecutive memory blocks. It makes it very easy for my database systems to compress the data. Okay, so whenever you say, and even if you go to ClickHouse websites, right, nothing fancy. They have some fancy words also, fancy techniques also, but this is the basic of OLAP system like ClickHouse. I will show you also. Mm, 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 mm. Yes, to Param's question, Param, they have 100% integrations with the data sources. So, yeah, see here, why is ClickHouse fast? This is the example I was just telling you guys that this is how row-oriented databases work. Every time new row will come, they will need to skip it, find the insight, and this is how columnar-oriented databases work. Every column will be of same data type. Compression is way faster. Compression algorithm we can talk about in some day. But because everything is saved in one column, maybe of same consecutive memory blocks, if I do sum of sales, takes me a second to do it. I don't need to do any overload on top of it. Okay. So this is why I explained you that whenever you see columnar oriented database, right? This is the base reason that why they are fast. I'll take a pause if I have anything in the chat. Is the data secure? Data is 110% secure because they have two options. One is, hey, you take my ClickHouse. store it in your own, host it in your own systems, right? That's a self-hostable option. In that, I will be maybe purchasing some VM, some IX6 VM, and could be of as much compute as I want, and then I will be storing it, and then it's in my own system. That, but the problem of that is, hey, the infrastructure hassle comes to your DevOps team, right? Then they have something called managed slash hosted cloud. In that, again, whatever data you store it, it's going to be there only. So all these companies, GDPR, CCNA, all those rules you can find, but they follow almost every policy written there. Okay. Yes, this was the one I was sharing, that you can have a purchase version of ClickHouse Cloud, and then you can set it up on your open source systems on the your personal computers also, right? This was the two reasons that why the reads are fast. Of course, there are multiple other reasons also, and I do want to explain you few more examples. Do you guys know what is encoding? Maybe before beginning, because the next pointer I want to explain is the encodings are way faster in ClickHouse. Do you know what is encoding? Do you know what is value encoding? What is hash encoding? Have you guys heard about these two words in the past? Have you heard about RLE? If you are from engineering background, this was taught to us in the classes. Run length encoding. Yes, yes, perfect. I'll just give you very quick example that how ClickHouse uses the same design patterns that we learned in the classes to make their databases faster. Okay, I'll do this and I'll try to explain you the value encoding first. So what happens when it saves the data or when it tries to read the data is value encoding. Maybe I'll do one thing. I'll try to create some IDs here. One column. Let's say we have a column called city ID. Okay, and let's say it had some dummy values. I'll just write something like 10016, not this, 100,215. Nope. Give me a second. Okay. So let's say there was a column called city ID. One way to save this column in ClickHouse would have chosen was directly take the entire column, save it in their disk. But it's not going to give them any benefit. Instead, what they do is, if they have data of this kind, they will do something called value encoding. Value encoding means instead of saving all these bytes, they will just store 14, 16, and 15. Now think, storing these many rows would have taken them a lot more bytes, but now they are just storing 2 bytes of data. Here they were storing 5 bytes of data. Because they have reduced the number of bytes it's taking them to store it on the disk, the compression is way faster. And of course, they do cap it somewhere. They will write it that 1K is the factor, that whenever you're reading it, just do the operation on this, and in the ending, you can multiply it by 1000, right? This is called value encoding. That, hey, don't save the entire thing, save it, divide it, the entire value by some common denominator, and then save lesser bytes. This is the one smart technique which these databases, the ClickHouse is using to do the encodings in the backends. There is another technique called hash encoding. Okay, what is hash encoding? Let's say, so this by the way is used for integer columns, and this hash encoding is used for string columns. Okay, what do we mean by that? Let's say you had a column called product, and you are doing the saving that data in fact table, and every transaction was getting traced. Okay, let's say it was some coffee beans, tea, bakery something, bakery something, and then again coffee or something. Okay, I think I should make it more obvious. Instead, what these tools like ClickHouse do is, because these are also just one rule to keep in mind, doing operations or saving data in a string format is the worst thing you can do. And you should be aware of this. And databases, of course, are aware of it. And there are, of course, very obvious reason for that also. But databases never recommend you guys to do operation on the string columns. Now, what happens is, instead of saving data like this, what ClickHouse will do is, it will save the column, but instead of saving coffee beans as coffee beans, maybe it will give it some specific code that coffee beans is 1, for example. So this will be saved as 1. And let's say tea and bakery were given code of 2 and 3. 2 and 3. Now, instead of saving the entire bytes of t, they will just write 2 here. Again, 2 lesser bytes. Here we had to save 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bytes. They saved it by just writing 1 byte here. Bakery is 3, so they will write 3 here. Whoops. They will write 3 here, they will write 3 here, they will write 1 here and 1 here. This is called hash encoding, where you are giving a hash number to your unique values like this, and then instead of representing and storing the actual values in the database in the disk, you are just saving the hashed encoded value inside your systems. This gets married to some other technology, other algorithm that is called run length encoding. So maybe I'll explain you that also. Again, I'm rushing around all this concept because I just have 1 hour to explain all of these things. But again, I hope you're getting the idea that every single thing these systems like Clickhouse are saving, they're using some smart techniques to store them, to compress them, to process them. Okay. What is run length encoding? Let's say you had some integer column and let's say you were storing some pin codes. Okay. One pin code was, let's say, 180011, and let's say a lot of people had this, and then there was some other code 122321, some random value. Okay. Let's say you had this column. Instead of storing the entire column as it is, they will do this. They will take the unique keys, save it here, and they will say that, hey, this code is written, what the hell, 1 2 3 4 5 6. So they'll write the frequency here. This code 1 2 3 4 5 6, same times 6 here. Now, instead of storing all these rows, 12 rows, my ClickHouse will save only 2 rows. First row will tell them, hey, this is the value. The second row is telling them for how many rows this is going to repeat. Same thing here, right? This is called run length encoding. This is also very widely used in the systems, OLAP system, specifically ClickHouse also, to save or to compress the data in much faster way. When they merge all these techniques, these are the reasons that you get to see the data much, much, much faster. Okay. Let me see the chat. Is the data secure? Range plus random. Yes. Whenever you generate random data, the dummy data, you either use range plus random or there is a library called faker, right? You can call it faker.js or faker.py library. You can use it for that. But these were the fewer techniques that things like tools like ClickHouse uses to make sure that the reads are very fast. So columnar storage is one, encodings is one, compressions is one. There is another thing called, maybe I should show you also, that is called sparse index. Okay. Whenever you are talking to someone and you want to sound very techy, you have to use 2 keywords. Okay. One is sparse index and one is merge tree. These are the 2 things that ClickHouse does and other tools are not doing. Right? Snowflake is not doing, Databricks is not doing. What is sparse index? So to explain you sparse index, I'll just give you one example. This will make life easy for me to explain you guys. Let's say you are saving some rows of data in your table. Okay. Maybe I'll give you some slightly easy to explain example. Let's say there's a bookshelf. Okay. This is a bookshelf and you are storing books into this. Okay. When typically normal OLAP system works like Snowflake and Databricks, whenever you're inserting a data, maybe inserting books into a bookshelf, they give you, you create something called index. Index means you know where every single goddamn book is present. Okay. That is called full index. But at one point of time, you start realizing that your full index is becoming so big, then you need something else to query faster on top of your index, right? Index, by the way, means storing the location of your data. Where is your each book or where is each row present? Okay. When you work with some other databases, they use full indexes that they know where each and every single goddamn row is present. But what ClickHouse does very smartly is they use, instead of full index, they use sparse index. Okay. What is sparse index? Give me a second. So instead of saving everything, they group the indexes and they saves instead of every single location, they saves the location of, let's say, n number of location, n number of rows into one single index. That means in other systems, one index represents one row. In ClickHouse, one index represents a group of rows. How many groups can one index represent? That's 8,000. That's written in the algorithm in the architecture. I can double tap on that why 8,000 is a specific number. But one index represent 8k rows. Okay. Now this is a smart technique to save the data. Why? Because now let's say I know that book 1 will be stored in index 1 and book 1 to book 8,000, for example, right, will be saved in index 1. Book 8,000 to 16,000 is saved in index 2, right? Now instead of parsing every index which was happening in the previous data warehouses, what I need to do is, if I have to find some book and I know that book number is, let's say, 9,000, for example, I will skip this entire index altogether. I'll skip the scan of 8,000. I'll directly come to this index, that is sparse index, because I know 8,000 lies between 8 and 16. I'll just scan this one. This is called sparse index row matching, and this is one of the reason that using this technique gives them way more advantage of getting the results faster. That they're not scanning the entire indexes, entire rows. They're just partially scanning the indexes. Okay. Of course, one problem here you would have realized is they need the data in a sorted manner. Otherwise, there is no way of using sparse index, right? If I'm saying that row number, book number 1 to 8,000 is here, and maybe some book number 6,000 is present here, it won't happen, right? Because how the sparse index works is you need your data to be sorted. All the sorted index, the 8,000 will be stored in one index, the next 8,000 will be stored in other index. Now this means you need to store your data in a sorted way. That's why whenever I was writing the code, here, right? I was writing the code here. I was telling you guys that always order by your data or sort your data. Sorting is one of the key factor that helps the ClickHouse to become fast, because of course they need their data to be sorted, and whenever you insert your data is always going to be sorted. Okay, this is one of the factor that why ClickHouse is faster. They use sparse indexing. One more thing I want to explain is merge tree. Okay, what is the meaning of merge tree? See, how the data is inserted or how the writes are fast is also because of the way their engine works. The engine of ClickHouse is called merge tree. Okay. What is the meaning of merge tree is whenever you are inserting your data is always inserted in one batch. They call this batch as quote unquote part, P-A-R-T. Okay. Let's say you inserted few rows today and the rows are inserted here. Okay, and of course you sorted your data, so you will have your new rows coming, and you, maybe I should not hurry, I will explain you one thing. Okay, let's say this is your table. I'll tell you what merge tree means. So let's say this is your table and you're trying to insert data into this table. Let's say we have just one column called id. Okay, let's say for the starting you are inserting things like, let's say, 20, 40, 10. Okay, these are the rows which are coming into your data. ClickHouse automatically, first thing they do is they sort the data. This will be sorted first, so this will become 10, 20, and 40, and this will be inserted inside your, of course, the inside your database, and this is called part. That means one ingestion is called one part. And one thing you need to know is you cannot change or you cannot alter your pre-existing data. So this is immutable quote unquote thing present in your data. Now let's say tomorrow, if new data is coming, let's say the data came was 5, uh, let's say 10, no, not 10, let's say 5, 7, and 12. Let's say tomorrow you want to insert this data. Now, how other systems work is, how other OLAP system works is, when they want to insert this data, they will try to sort this right away. That means, I think I should have done it in a better way. 10, 20. 40. Okay, let's say this was the data which came when I was first inserting my data. But when new data is coming, how other systems behave is they will try to sort the entire data first. Means, I give you example here. 5 is coming and 5 should come before 10. So they will first arrange the data here and then insert 5 here. Of course, 7 need to come before 10. They will arrange the data 7 here as well. Then 10, 12 needs to come. They will arrange the data 12 here. And this happens. And this thing is happening in real time when you're inserting the data. This is one of the reason why writes are not that fast in systems like ClickHouse and Snowflake. Not in ClickHouse, but in Snowflake and Databricks. How ClickHouse manages the inserts or writes is they will not sort your data when you're inserting it because the part is immutable. You cannot change this part. What they do is they will insert this after the part is inserted. They will just sort this part, means if data was coming like this, for example, 7, they will sort this part that hey, 5 should come first, 7 should come second, and 12 should come third. This is part 1, for example, which are already inserted. This is part 2. Okay, internal parting sorting is allowed. They will sort the data, but they will insert it directly on the disk. They will not try to sort pre-existing data. That means data will go like this, 7 and 12. This is my part 2. Because they don't need to worry about what was already present in their system, the writes are very fast. Okay, if this was other system like other OLAP databases, you already know that hey, they try to sort the data again and again, right? But ClickHouse say I don't give a damn. I'll just sort my data in my current part and I'll insert it. Now this data is not sorted. This is where the backgrounder comes. They have something called backgrounder, and this runs when you're not doing anything. Backgrounder has the merge technique. That's why the engine is called merge tree. Once you are done with it, once your inserts are done, in the backend, automatically the sorting within the parts will happen. That means the sorting is not happening when you are inserting the data. It is handled automatically by the ClickHouse's engine whenever the data is inserted. That's why the writes are fast. Reads are fast because, of course, I told you the reasons, right? The compressions, the columnar storages, and the sparse indexing. This is very dumbed down example. Of course, the lot goes behind the scenes, like how the parts are created, how the granules are created. There is something called granules. There is something called merge tree. But in nutshell, okay, just explain it like a 5 years old. This is how the inserts are happening in ClickHouse, and that's why even their name, the name of the tool is ClickHouse. The meaning of click is clickstream. That means clickstream data means every click the data is getting logged, means a lot of data, real-time data. House means warehouse, right? So you're doing your analytics, you're doing your warehousing stuff on the clickstream slash real-time data. And why ClickHouse is fast is something called merge tree. Merge tree is their algorithm, is their engine. If you guys remember, when I was writing code, this is the CRM by the way, which I was writing yesterday. Mm, where is my code? Damn. Give me a second. I was saving it inside ClickHouse POC, right? Yes. So if you remember, when I was writing my code, I told it that use the merge tree engine, and that's why the inserts are very fast because whenever you're operating on it, right, it is just creating a part of the data and storing it. It's not sorting the entire data. Again, multiple other reasons also why ClickHouse is fast, but these are a few of the reasons why it's just a it's just a peak experience of using ClickHouse. Okay, why the database system like requires sorting at first place? Because see, they are solving very different problem statement. They are trying to make or trying to solve batch analytics faster. Okay, how their specific. Okay, maybe I should talk about Snowflake versus ClickHouse a bit more. How Snowflake works, by the way, is they have something called compute layer, compute, and they have storage layer. Okay, how Snowflake works is they have isolated or decoupled your storage layer with the compute layer. Okay, that means your storage data typically sits in S3. This is the magic of Snowflake, and you run something called warehouse. And these are independent of each other. That means if I am running my compute in my laptop of Snowflake, my data is residing on S3 servers. That means my query has to go to network. That's a IO call, right? Network slash or IO call, right? When I use ClickHouse, it's a single node system. That means I'm not decoupling my storage and compute. That means my data plus my compute is residing in the same memory disk. That means I'm completely avoiding this pattern. Okay. To your question, why Snowflake is trying to sort the data? Snowflake, to be very frank, whenever they insert the data, right, they also have to make the data reading easy. Everyone wants to read the data easy. ClickHouse also wants to read data easy. Snowflake also wants to read the data easy. Reading data is only easy if the data is sorted. If the data is not sorted, your data read will be slower. Of course, right? If I give you a book and if I ask you to find a word, right, you won't be able to find it if I don't give you the index. Index means that it gives you the technique to sort the data, to find the sorted data, right? Everyone wants to have the data sorted, but the way Snowflake sorts the data was entirely different than the way ClickHouse sorts the data. So it's not that Snowflake is sorting the data, ClickHouse is not. It's just that the design pattern that both companies have followed is entirely different. Okay. By the way, Snowflake versus ClickHouse is a good comparison. I can show you a few more nuances also. So if I go to the ClickHouse website, ClickHouse. They have a benchmarking page specifically for the cost and the compute. I will show you just for the Snowflake, okay? Yes. For example, the first one is, of course, the difference is deployment. You can't have the self-hosted, self-managed system in that Snowflake. That's the first one. High concurrency, it can handle 1,000 QPS. QPS is queries per second. But in Snowflake, you need to start your clusters again and again. You need to add VMs to the Snowflake again and again to manage that. Of course, the reason is the way the architecture works. The Snowflake works on micro-partition architecture, right? Maybe we can have a separate discussion of how that is different from the current ClickHouse system, but Snowflake was not optimizing the warehouses for writes. Snowflake was only optimizing the system for the reads. ClickHouse is optimizing for the reads as well as the writes, right? And again, because it's for real-time ingestion, it takes me less than 1 second to ingest the data, but Snowflake has a 5x more ingestion timings, right? Again, elastic scaling is also possible in Snowflake. That means in Snowflake, whenever you have to upgrade something, you have to specify how much compute I need and when it should upscale or up, maybe at what size of a warehouse do I need to upscale it. In ClickHouse, it doesn't matter, to be frank. You can just have a minimum compute present here and then you can scale it vertically and horizontally also, right? There are cons of this technique also, but maybe time won't allow me to cover it today. But what else should I show? Yes, one of the another very good reason of using Snowflake ClickHouse is if you see the engines which ClickHouse supports, you can use almost every engine present in the world because it's open source, right? But when you come to Snowflake, whatever object storage you are using, you will need to be bounded to that specific reason. If you want to do any query ingestion, right, you are supposed to be using only those functions that Snowflake supports. When you use ClickHouse, use any table format, use iceberg, use hoodie, anything you can use and it will support that. One of the reason that why it supports Snowflake, by the way, file formats also only Parquet is supported. It support ORC, OCR and JSON also, Avro also, right? Few of the reason, but I will give you the entire link that hey, why is it different than Snowflake? Okay, let me check the Q&A. ठीक है, अभी यहाँ पे नहीं है. In case you guys want to know how Snowflake works, like why writes are not partitioned very well, just search Snowflake micro partition strategy. Okay, micro partition strategy. This is the thing you guys will need to see to differentiate the snowflakes working versus the ClickHouse working. Okay, I think their documentation will give you the insights. Let me see. Yes, this is the diagram. Again, go through the link. I will paste the link in the chat. This is a diagram that will explain you that why writes are slower in Snowflake. Okay, so I should post it here. And yeah, I think we should be good for the day. I hope you learned something new. The point of this class was to tell you why you should care about ClickHouse, because people think that because they are using only Databricks and Snowflake in their companies, that's the only thing that is possible. But when you have a product, when you want scale, these tools won't work, right? Because we are talking about a scale. You can do it live, take the same code which I wrote in the class, run it on Snowflake. You will find the latency, you will find the lag, you will find the freshness problems. And then I'm not even talking about import the millions of users, right? When you talk about that scale, Snowflake and Databricks doesn't work. And that's the place where ClickHouse works, right? And because it is open source, one more point I want to add is nowadays the companies are shifting towards the open source tech stack because everyone is trying to create their own products. Everyone wants to create their own tools, right? How do you create your own tools without incurring a lot of cost? Only if you know that there exists open source tech stack. There's a very good amount of open source modern tech stack. Companies are following that also. This is also one of the reasons that you should be aware of all these tools. Okay, and of course, it's always good to know that if someone is saying I'm 5x faster than Snowflake, who is that person, who is that tool, and why they are faster? So it's always good to upskill on that perspective also. Okay, so this was for today's class. I will give you a brief glimpse about the course. This class, by the way, is part of the cohort which I teach. That is, how do you become a data solutions architect? When you think of solutioning, right, these are the things you need to be aware about, because if you are coming to as a consultant to a client, they are giving a problem statement of, hey, suggest me a warehousing tool where I want to cater real-time analytics to millions of users. You can't tell them use Snowflake or Databricks, right? They'll show you the door within a minute. This is one of the reasons that whenever someone works as a solution architect or as a consultant, they need to be aware of every single tool which exists, every single technique which exists, why one tool is better than other tool, in which places one tool is better than other tool. These kind of things are covered in this cohort. I know a lot of you which are in this class are already part of it. Uh, Sorin is part of it. Param is part of it. And Sandeep is part of it, right? So all of you, Ashwath is also part of this cohort, right? So most of you are already part of it. But if in case someone is saying and they haven't enrolled for this course, the course is starting on the 15th of August. The purpose of this course is to make you end-to-end realize how does the architectures work in real world, when to choose which tool, and how does the tool interact with each other, right? Nowadays, building solutions in silos is not going to help you guys. That means if you just know Snowflake, it's not going to be a big deal. The real value or real mode lies in that, hey, I can integrate all the tools with each other to build a solution, right? Solution is a big thing. That's why this course exists. The first batch is going to be started. The first batch of 2026 is going to be started on the 15th of August. I think next to next week. 70 hours of content, 20 plus tools, all use case based, no theory, no jazz of that kind. You will find all the cohort, all the content here. So you can go through the content and yeah, you can enroll to the course. I will paste the link of the course in the chat. And if you have any question, you guys can ask me either in LinkedIn or on the email. Okay, so I hope we are good for the day. Thanks a lot for joining. We are meeting tomorrow again. If in case you guys are curious, what does it mean to build solutions? So I'm covering that topic tomorrow. That what is mean to be becoming a data solutions architect? So yeah, if you like today's session, we can meet tomorrow also, and we'll talk more about these kind of things only in tomorrow's class. Thank you. Thanks a lot for joining today's session. Thanks, team.